Okay, put this one. Y equals negative x minus 2 squared plus 4. Plot that one from 0 to 4. 0 to 4 on the x. Start more simplest. Ah. Trying to make lines. I wanted. I just want the whole thing above. We don't technically need any of this. Also, when you draw this, if you're drawing it for your own welfare, cool. But you should still write x scale 1 and y scale 1. 0, 1, 3, 2, 4. Yeah. It'd be easier for you guys to visualize left side if I make it this way. So that's technically the graph. It keeps going, yes? But do we care about the rest of it? No. Okay. I'm going to have it equally partitioned into 4 pieces. So that means I want to have
0 to 3 or 0 to 4?
Oh, it's 4. Does this one come down here? Yeah. Okay, so I want partitions from x equals 0 to x equals 4. 4 partitions. And then I want left. Left room to sum, so we're going to do first. All right, everyone paying attention, because I will lose you. I lost you with the upside down one, so I'm going to do it all right side up. So we'll do red for left. So I'm going to break it into 4 partitions. I actually have 5 numbers from 0 to 4, correct? 0, 1, 2, 3, 4. Yes? If I took a, I'll draw it as a number line, maybe this will help. So if I have 0, 1, 2, 3, 4, do we agree? I want the left-sided heights. If I pick the left and the right, they're totally different heights, correct? So I'm going to do the left-sided ones. So the left-sided ones would be this height, the height of this one, the height of this one, and the height of this one. We agree? If I pick the left ones. So watch, I'm going to go to this one. What's its height?
0.
So when I draw its rectangle, it's going to be like this. Because you get this height and you draw at a distance of 1. Why am I drawing at a distance of 1? Because there's 4 partitions. And if you want the change in x, so you want to know the change in x equals the width. If you want to find the width, all you do is you take your x's, so 4 minus 0, and you divide it by partitions. So it's a difference of 1. That will get you your width of each of your rectangles. And if you look here, you'll see that's the width. 1, 2, 3, 4, right? It's not strong to scale, it's extra long. But unless. So you get 4 minus 0 for your x's. Change in x over partitions.
How do you know you're you just like choose you're doing 4 partitions?
No, I told you that.
Oh.
Yeah. All right. So, this is my left. Do we agree? Okay. Now this is the left height of this one, is it not? Now I need to make a rectangle with that. Is my change in width changing? No. So this is the area of the first rectangle. It's literally nothing. Then we go here. We follow it up. And this is my height. So this is the area of the second rectangle. Okay? It's based off of the left-hand height. Now this one, so that one's, basically this one's extremely underestimating, the first one. This one's a little underestimating, yeah? What's this one going to do? Overestimate, because I would draw it over till it hits that part. We still have the partition of 1, width of 1, sorry, and that's going to be our rectangle. and then we're going to use 3's height to make the 4th rectangle, right? Like 0's height makes this rectangle, 1's height makes this rectangle, 2's height makes this rectangle, 3's height makes that rectangle. So we're going to follow it over. And now this one's overestimating. Do we agree?
Yeah.
So they said if I put rectangles underneath, I can get some sort of estimation. Is this one going to be perfectly accurate? Is the area going to be just wonderful? No. But they said that we could do it this way. If I split it into more rectangles, so instead of 4 partitions, I split it into 8 partitions, would it get better?
Probably.
Yeah? If I split it into 100 partitions, would it get better?
Yes.
What about 1,000? Million? So that's when they figured out that the integral, the antiderivative, splits it into an infinite number, and you get yourself an accurate area. Okay? Now, you might be like, why do I have to do left partitions? Because they'll ask for them. They'll ask for the area using left Riemann sums. So how do we get that area? Well, we just find the area of these 4 rectangles, right? So this would be area 1, area 2, area 3, area 4, and you're going to get the answer. Now, if you're someone who has a calculator and you put it into integrals, and it gets you an answer, and you circle that one, you're wrong, because that's not what the left one's going to give you, right? So people are like, well, why would we just get an accurate one? Because they can ask this question, so we have to be able to do it. And they will. They'll ask for left or right or midpoints. So we're going to do left first. So the area equals, what's the first rectangle's area? It's 0 is its height, and what's its width? 1. So we just keep that. Plus, what's area 2?
3.
So it has a height of 3, and what's its width? 1. Plus, what's the height of area 3? 4, and what's its width? 1. Plus, what about the 4th one? What's its height? 3, and what's its width? 1. And so that cancels. So we're going to get 3 plus 4 plus 3, which is 10 square units. I am for sure using the wrong computer. This one doesn't have the extend page. I'll have to redrive. That's good. Okay, so that's left Riemann sums. Yep.
Why would we ever do left Riemann sums if we have a more accurate method of solving?
Because you have to go through the methods that were taught in the past.
It's just what they did back in the day before they had TI-84 calculators.
Yeah.
Yeah, but that's done and we have the 84.
It's in the curriculum. If you don't want to do that, you shouldn't take the class that has it in the curriculum. It's a crazy thing how it works. I have no control over the curriculum. I teach you so that you're prepared. Okay, so, right. Also, if you just memorize how to do things, you never really understand where someone came from. You can't learn other things and possibly come up with new mathematics. Right? Okay, so if we do it from the right, we're going to do the same thing. In the fact that we're going to draw the same graph. So we have 0, 0, 1, 3, 2, 4, 3, 1, no, 3, 3, 4, 0. See why I made it be above the whole thing? It's a lot easier to like actually see the rectangles when they're all on top of the x-axis. Okay. So the way I figure out what numbers I need to pick, so here I have 1, 2, 3, 4, and 0. I'm still partitioning it into 4. The only difference is I'm taking the right-handed ones. Well, if I'm partitioning it into 4, I can only get 4 areas, correct? So which of the numbers am I using this time? 1 would be the right-handed side of that rectangle. 2 would be the right-hand side of this rectangle. 3 would be the right-handed side of this rectangle, and 4 would be the right-hand side of this rectangle, and 0 I no longer am using, because it would be left. So if I want to do use the right-handed side of this one, okay, this is where the actual rectangle's height is going to be based off of. I follow it up to that height, and then I have to make a rectangle with it. Correct? Yep. Does not matter. Yeah. Every way's easier for you to draw. So now this one's grossly overestimating, right? Now for 2, we follow it all the way up, follow it over, follow it down, area 2. Then 3, we follow it up, follow it over. That's a little underestimating. And then 4, once again, we're back to that height. Now, I picked something that's symmetrical, so it does make a little bit of a difference, but it's not always going to be symmetrical, right? So our area 1, our change in x doesn't change, correct? It's still 4 minus 0 over 4 partitions, which is a change in 1, which is our width. So the area is going to equal area 1, which is a height of what? 3 times 1. Plus area 2, a height of 4 times 1. Area 3, 3 times 1. And then this one is a height of 0. Which is 10. Weird. Are the left and rights always going to be the same? No. No. I told you this one's unique because I made it what? Symmetrical. So left and rights would be the same. Okay, so they said left bound, not so good. Right bound, not so good. Still above too much or sometimes too little, right? It depends on what the curve is. So they said, what about midpoints? So what if we did midpoints instead? Do another page. Draw the graph. So now we still have to draw, guys, the graph. So we have 0, 0, 1, 3, 2, 4, 3, 4, 4, 0. All great, lovely graph numbers. But if we're doing the midpoint, do I actually use any of those y values as my length of my rectangle? No, I'm going to use the midpoints. So I'm going to need to find out what those are. So the first one I'm going to look at is 0.5. So, guys, does the width of my rectangle change? No, the width of my rectangle isn't going to change. Change in x equals 4 minus 0 divided by 4 partitions, which is still 1, which is my width. Does the height change? Yes, it's going to be where 0.5's height is. 0.5 has a height of 1.75. So I follow that over, down. So this is 1.75. That's what that height is. So now we're doing midpoints between the middle of those points. So here we have 0 and 1. I'm going to use 0.5. The next one I'm going to use is 1.5. And so I get 3.75. Help myself out. So I follow it up. I split it over and down, over. Ooh, that's not a good rectangle. So it's that middle height. It's the midpoint. This is area 1, area 2. Then we're going to do 2.5. So you can speculate what that's going to be. Because I picked a symmetrical one, it's 3.75, so it's here again. So I'm going to get 2 rectangles that are side by side, same height. because you're taking that middle height, drawing it over. So some of it's below, some of it's above, right? Area 3. And then this one's going to be at 1.75 again, because I picked a symmetrical one. Now, because this is symmetrical, could I find the area of the first half and then times it by 2? Technically. So, the area under the curve of this one is 1.75 is my initial height, that middle point height, times my width, which did not change, which is 1, plus my next height, which is 3.75, times 1, plus my next height, midpoint height, which is 3.75, and 1, plus my last one, which is 1.75. What does it give me?
10.
Why did this one give me 10? It's symmetrical. Once again, it's symmetrical. So I have the same amount above as below, same amount above as below. It's your 11, not 10. Can you not add?
It's 11.
Oh boy.
Oh, brother.
Oh brother from another mother. Okay. Now, because we only partitioned it by 4, midpoint is better. You have a bit above, a bit below, right? Left, you might have all above, below. Right, you might have all above, below. Midpoint's kind of better. 4 partitions, obviously not the most accurate. You have a lot of area above and a little area missing, correct? What is the actual accurate area? So we have 0 to 4. And what was f of x again? I don't remember where you put it.
Negative, in brackets, x minus 2 squared. Okay.
We are not using our calculator to find this, because it's in a non-calculator section. I'm showing you something early. It's called the fundamental theorem of calculus. What I'm going to teach you, you haven't learned anything. Just chillax. So, we have to expand this, because currently we can't do the antiderivative of this the way it sits, right? So let's expand it out. So we're going to get 0 to 4 minus x squared minus 4x plus 4 plus 4. And then it equals 0 to 4 negative x squared plus 4x minus 4 plus 4. So technically I get 0 to 4 negative x squared plus 4x. Have I done any derivatives of anything? I just rewrote the equation. Some people are like, we're done. I'm like, no, you have not derived anything. So in order to get rid of the integral symbol, you actually have to do the antiderivative of it to get back your original. Okay? So that's what we're going to do first. So I'm going to go equals, and I'm not going to do the integral symbol because I'm going to make the integral symbol go away by doing the antiderivative of it. So what's the antiderivative of negative x squared? Negative 1 over 3x cubed. Raise the power of 1 and then divide by it, yeah. Plus 4x to the 2 now, divided by 2, plus c. Do we agree? Now, this is from a specific value. So if it didn't have 0 to 4, you'd be done. But this is actually a specific value, which I have not done yet. And you can't keep the integral symbol. If you keep the integral symbol, you're saying it's an antiderivative. Yes? We don't want that. So the way that we show them, the values of 0 and 4 still need to be inputted, is we put a little square bracket at the back and put 0 to 4. So that we know we're still finding the area from 0 to 4, but we don't have the antiderivative, or we don't have the derivative anymore, we have the antiderivative. And I'm going to make this a little bit better. I'm going to make it be a 2. That looks terrible. Don't do that on the test. Write an extra step. I have no more extend page. I've extended the page to where its max is because this stupid update was run for a second. Okay, the fundamental theorem of calculus states if I want to actually figure out what the heck that is, I literally just plug 4 in, and then I subtract, plug 0 in. That's it. So to do the math of this, I just go plug 4 in first. So I go -1/3, 4 cubed, plus 2, 4 squared, plus C, minus, do the exact same thing, but with a 0, which is going to do nothing, because they're all cubed and squared. Now some people say, well, what do I do with the C? I don't know what it is. Well, you have an add a C and you have a minus a C, so the C's disagree and go away. Now what happens when I have -1/3 times 0 plus 0? This also goes away. So really it's just going to end up being the answer to this. So what does that one equal? So we get 4 cubed. What's 4 cubed? 64 times -1/3. -64/3. Which actually reduces to. If you don't remember, you can do division. Yeah. Huh?
It doesn't go
18?
No, I lied.
It doesn't go
I know it doesn't, Marisha. Because you can have your calculators taken away. You guys need to remember how to do long division. And by you can, half of your test does not have a calculator. So 6 goes into 3 goes into 6 2 times. I get a 6. Subtract 0. 4. 3 goes into 4. 1 time. I put a 3. I subtract to get a 1. I go, oh crap, it doesn't go evenly. 63 does. 64 does. Right? So it just stays that. Plus. Now what's 4 squared is? 16 times 2 is 32. And how do I put them together then? Same base. So I'm going to multiply by 3 and 3. So I'm going to get -64/3. Plus, what's 32 times 3? Over 3. What's 96 minus 64? 52. Can that reduce any more? What is 32 divided by 3 as a decimal?
10.67.
So they're really close, right?
10.66.
The answers were actually quite close. If I had to buy building material off of it, we'd be in trouble. I would have a little less and a little too much, but that's, yep. So does that make sense? Not too bad, right? Not too bad. So today's lesson, or today's homework will be on left partition, right partition, and midpoint.
I did read it more yesterday. I'm like,
So we're